Hi, my name is Jennie LaBonte, and I am in your 115 Tuesday, Thursday physics class. And for my podcast, out of the list of experiments, I chose Crash, number 55. And the point of this experiment is to prove that a moving object will not be stopped due to its resistance to change, basically its inertia. So for this project, instead of doing the little toy car and the little clay figure, instead of that, we're going to do the real thing here. And instead of the toy car, we have a real sports edition Ultima with leather interior. Look how nice that is. Yeah, it's an Ultima. Yeah. And then instead of the little clay figure today, we will be using the awesome bear. It's not going to have an awesome day today. I couldn't find a cat, but this was the closest thing, so sorry. So that's what we're going to be using today for our experiment, and how we're going to do this is instead of using the ruler and instead of using the books to make the speed of the car increase, we're going to be just increasing the speed of the car. So we're going to be doing increments of that, and that is going to take place of the height of the books. And we have lines marked over there, which I will show you. One moment. Okay. And so for the lines where the car will be stopping, we have actually these white lines here, at which the car will come to a complete stop, where causing the bear's inertia to keep going because due to the resistance to change. So the bear is going to continue to keep going, and we're going to do 3 trials to see how far it actually takes for an outside force, gravity, and air resistance to make a impression on the bear and stop it and make it come to a complete stop due to the friction. Okay, so we're about to do the first test run here at 20 miles per hour to get more speed. We had decided we had to do that. Sorry. Okay, so the bear went pretty far, so we're going to take exact measurements here and figure out how far it went. And the line there was acting in place of the pencil, and the pencil was also taking place by the brakes of the car, which was the object, the force outside to stop the car, and the bear, which didn't have anything to stop the car, which had it had inertia, and it just kept going until something stopped it, being the ground. So we're going to see how far it went on the first run at 20 miles per hour. 20 miles per hour. Alright, so the first test did not go very far. That was 20 miles per hour. So since it didn't go very far, we're going to up it about 10 miles per hour. Why not? Well, not only did that sound like it killed my brakes, I think that actually did not go as far, but we'll do some exact measurements and find out. First, let's do the last test, test 3. Okay, so that was the second test, and then for the third and final test we have here, we're going to try and get it up to 40 miles per hour.
I can tell you.
Well, might have been a little bit past the line. We'll do that again though. But the bear did go further, even though the car was a little bit further past the line, so let's try it one more time. There we go. It's a little better. We're more on cue with that one, so those were the 3 different trials we did, so now we're going to see what results we actually got for them and what they had to do with inertia. As every good scientist knows, not all experiments go as the way they're supposed to, which is kind of the case in this situation, because we found here that the results were not exactly as they were made to be in the experiment, because in the experiment the faster or the higher the books were, which made the car faster, made the clay figure travel further. Well, in our case, the slower the car was at 20 miles per hour actually made, I don't know if I can see it, crap, actually made the furthest line, and then when we started going faster at 30 and then to 40, we had the shortest line. I don't know if you saw that, it's kind of hard to move this thing, but yeah, so it actually went exactly backwards, but in some case that could make sense, because if the car was traveling slower, we actually could become more precise with where we actually stop, as with a faster speed, it's harder to actually be able to tell where you're stopping. So it's all human error. It's not going to be perfect with every experiment, but since this is an actual hands-on experiment instead of a little car, it's a little different. But we still got the same basic result. The car was going as like the clay cart and was stopped by the brakes, which was the pencil in the experiment sheet, and a little clay figure going due to resistance to change or inertia, and was stopped by gravity and air resistance, which was the same for Mr. Awesome Bear here. So yeah, he had the same kind of thing going, and it just kept going when the car was braked or hit with the pencil. So that is my project, and that was number 55, Crash. That was my own interpretation of it. So I hope you enjoyed my trials, and thank you.